Alright, today we're looking at the second fundamental theorem of calculus. So the last video was on the first fundamental theorem. This is the second fundamental theorem. So I want to start with this problem. We're asked for the derivative of the integral from 0 to x of 3 square root of t dt. So let's actually go through this process. Let's do the integral from 0 to x of 3 square root of t dt. So that's going to be 3t to the add 1, 3 halves, divided by 3 over 2, plus c. Well, no plus c. It's a definite integral. We don't need the plus c. From 0 to x, and then we're doing the derivative with respect to x. All right, we plug in the upper and lower bounds. So we have the 3's cancel, 2 moves to the top, so 2x to the 3 halves from 0 to x. Now, once again, we're working from inside out, so we need to finish this integral before we can take the derivative. Also, variables don't match up. This is the derivative with respect to x. This is the integral with respect to t, something to keep note of. All right, so we're going to plug in, this should be t still, not yet x yet. Now we're going to plug in x. So we have 2x to the 3 halves minus 2 times 0, which is just 0. Oops. So we're just left with this. And now we're doing the derivative of this. So we'll pull down the 3 halves. We'll have 3x to the 1 half. And that's it. There's our derivative of this integral. So one thing we notice is that when we do the derivative of the integral, we end up back with the original function. Now this seems pretty obvious. They're inverses of each other. The integral is the opposite of the derivative. We started by calling it the antiderivative, so it shouldn't be a surprise. The big thing is the connotations that come out of it. Like for example, let's say we change this to 2x instead. Well, that means we'd be plugging in 2x here, and when we did the chain rule, we'd end up with a times 2 on the outside. So in this case, we ended up with the same function with 2x plugged into the inside, and then times the derivative of 2x. So that means chain rule has to apply in this case as well. This leads us to what we call the second fundamental theorem of calculus. The derivative of an integral is that function with x plugged in. But it's not just that. If you do the derivative of an integral with a function that you're plugging in, let's call this g of x, f of t dt. Well, that will plug in g of x, but it also multiplies by the derivative of g of x because of the chain rule if you were to go through the full process. Or if we take this a step further and say this is from h of x to g of x, well, that'll plug in h of x as well. So minus f of h of x times h prime of x. Once again, chain rule has to apply. So we're doing the integral, which is plugging in the upper and lower bound. We're taking the derivative, which leaves those plugged in, and then we're multiplying by the derivative of what we plugged in. Okay? So in this case up here, this one, there's still an a being plugged in, minus f of a, but we're multiplying by the derivative of a, which is 0. In the one we just did, there's still an 3 times 0 to the 1 half, times, and then the derivative of what we plugged in, which was 0. Because if this was a constant, let's say this was 1 or something, say that was 1, then you'd have a minus 2 times 2 to the 3 halves. You have a constant there, so when you take the derivative, it'd go to 0 anyway. All right, so this is the idea behind the second fundamental theorem of calculus. So let's look at some problems with this. For most of them, it's just going to be as simple as, hey, derivative of x. We have an integral of x, so we'll plug in the x squared plus 5 times the derivative of what we plugged in, which is 1, minus, we plug in the 0, so square root of 5, times the derivative of what we plugged in, which was 0. And we'll simplify it, so square root of x squared plus 5. Easy enough. All right, but we'll see some that are a little more complex, some like these. We'll plug in the upper and lower bound, so 4 times 3x squared times the derivative of what we plugged in, minus 4 times square root of x squared times the derivative of what we plugged in, which is 1/2 x to the negative 1/2. Right? And then we'll be required to simplify this. So this is 3 squared, which is 9, times 3 is 27, times 4 is something big. 8, 2, 8, 9, 10, 108. Minus, and then the squared over the square root will cancel out, so we have 4 over 2, which is 2. X over x to the 1/2 is x to the 1/2. And so it would simplify this way. And you can see more problems like this through practice. So if you want a couple to practice on, here are a couple more. Let me know if you have any questions. Y'all have a great day.